Hello guys, in this video we are going to discuss about the tricks for Newton's laws of motion. So this is the part 6 of the series of videos for NEET and JEE. By watching this video you can understand the concept of blocks which are placed in a horizontal plane. So again welcome to IB360. So proceeding on to the first question, we have two blocks. Okay, so one block is of mass m1 and the other block is of mass m2, and the m2 block is actually pulled forward by a force of capital F. So we need to find the acceleration and the tension in this string. Okay, so over here we know that the formula for acceleration is nothing but the total pulling force minus the total resisting force divided by the total mass, your capital M, right? So now over here the net pulling force will be equal to, see over here, see that this block of mass m2 is actually pulled forward with the force of capital F, राइट सो इस मास को हम फॉरवर्ड खींच रहे हैं विद अ फोर्स ऑफ कैपिटल एफ. सो ओवर हियर द नेट पुलिंग फोर्स विल बी हाउ मच? कैपिटल एफ. Right now the question arises, does this m1 or m2 provide any pulling or resisting force? ये क्या कोई pulling or resisting force provide करेगा? So this is the main question now. So in order to understand that, let us draw the free body diagram of either of the blocks. You can choose any blocks. I am choosing the block of mass m1. So over here on this block of mass m1 we have draw the free body diagram. So over here we have a force of n1, that is the normal which is coming up from the ground. So this is the ground and the ground will give a normal on the block of mass m1, right? And the weight of the block of mass m1, that is your m1 g, acts downward, and over here we have the string, right? And string provides tension force, okay? And tension always acts away from the body, right? So that means over here in this direction will be our tension. So over here you can clearly see that the normal and the weight will be acting in such a manner such that these two are balanced, right? So that means in the y direction n1 is equal to mg, right? So that means these forces are actually balanced. So that means in the y direction there is no net force, कोई भी फोर्स नहीं है y डायरेक्शन में. Okay, now come in the x direction. So over here you can see that the tension T is actually trying to pull the block of mass m1 forward, right? It is trying to pull the block of mass m1 forward. Okay, so that means our pulling force should be F plus T, right? Should it be F plus T? No, the answer is strict no. Why? Because tension is a internal force. Will not take any internal forces in this equation. Okay, internal forces will cancel each other out. So that means we'll not take any internal forces in this equation. Okay, all forces are external forces. So over here you can see that we are externally pulling this system with the help of the force capital F. That's why the pulling force is your capital F. So mind it, we will never be taking tension in the pulling force or in the resisting force equations. Okay, so that will just mess things up. So in conclusion I want to say is that if you just take a block which is normally sitting on the ground in this manner, what will happen? It will not provide any pulling or any resisting force. I hope I'm clear with this. If you have any doubts, just ask me in the comment section. I'll be more than happy to answer. So similarly same for the block of mass m2 only. Block of mass m2 also. Okay, on the block of mass m2 there will be a force of tension T backward, but will not take that tension force in this equation. Okay, because that is an internal force. So in conclusion, all the blocks that are laying flat on the ground, they will neither give any pulling force or any resisting force. Okay, so that's cleared out of the way. Now try to solve this equation. It's very easy. Okay, so that means in this system the net pulling force will be your capital F. So now what will be a resisting force? Over here, can you find any external forces which are trying to resist the motion? No. Over here, the weight of this block mg, which is an external force, is balanced by the normal, right? So that means no external force provided by this system. Similarly for this block of mass m2, over here there is the normal n which is actually balancing out the weight of the body, right? So that means neither this one will provide any pulling or resisting force. So that means the net resisting force will be over here 0, right? So that means the acceleration will be the total pulling force, that is your capital F, minus 0 divided by the total mass. Total mass is m1 and m2, so that means this will be equal to your m1 plus m2. So that means from here our acceleration a comes out to be your f divided by your m1 plus m2. I hope I'm clear with the how to find the acceleration. Okay, so we need to find the tension now. So that means this is the free body diagram of the block of mass m1. Okay, so downward will be our weight of the body, that is your m1g. Now the ground will actually give a normal force upward, so that means the normal force coming from the ground will be n1. Okay, and over here we have a string, right? So that means this string will provide us the tension force. So that means this will be a tension force T, which is actually away from the body, right? Tension always acts kidhar lagta hai, away from the body, right? So that means over here, and we know that the acceleration of the system is nothing but f divided by m1 plus m2. Where will be the acceleration? See, this side is the force, right? So that means in this direction will be our acceleration, right? So that means this block of mass m1 is also moving with an acceleration of a in this direction, right? So that means I can write that the summation of net forces along x-axis will be equal to your mass into acceleration. What is the net force along x-axis? In the x-axis you can see the tension Tx, right? So that means the net force along x-axis will be T. So T will be nothing but equal to, what is the mass of the body? m1, right? m1. And what is the acceleration a? Acceleration is a is nothing but f divided by m1 plus m2. So f divided by m1 plus m2. So we have easily found the tension also. So this type of problems is very very important for NEET. So if you have any doubts, please don't hesitate to comment in the comment section below. I'll be more than happy to answer your doubts. So so don't hesitate. So let's just proceed on to the next example, so for your better clarity. Thank you. So hello guys, proceeding on to the second example. So over here we have so hello guys, proceeding on to the second example. So over here we have three blocks, m1, m2 and m3, and m3 is actually pulled forward with the force of capital F. So we need to find the acceleration first. So what will be the acceleration? Acceleration will be the total pulling force minus the total resisting force divided by the total mass capital M. Okay, so over here the net pulling force, see over here we are pulling this block of mass m3 with a pulling force of capital F, right? So that means the pulling force will be capital F. Now over here we have discussed in the previous example that this block or this block will not give any pulling or resisting force. Okay, as this block is kept in a horizontal plane, it will not give any pulling or any resisting force. So that means the net pulling force will be capital F only. These blocks will not give any pulling or resisting force. Okay, now over here what is the net resisting force? The net resisting force will be 0. Why? Because we are pulling forward this block of mass m3 with a force of capital F, right? And this block is not giving any pulling or resisting force. This is also not giving any pulling or resisting force, and this is also not giving any pulling or resisting force. So the net resisting force will be 0. So over here the acceleration comes out to be capital F divided by m1 plus m2 plus m3. Okay, I hope you got this. So you have easily found the acceleration, and once you understand this concept that the blocks which are placed in this horizontal plane will not give any pulling or resisting force, you can easily solve it within a matter of seconds. So it doesn't even matter. Okay, so we have easily found the acceleration to be f divided by m1 plus m2 plus m3. Now over here let us find the tension. So over here suppose I want to find the tension in this string. So we want to find the tension in this string. So over here let us draw the free body diagram of the block of mass m1. Okay, so this is the block of mass m1. Downward will be acting the weight of the block, that is your m1g. Upward will be the normal that is coming from the ground, that is your n1. So over here in this side you can see there is this string, right? And string provides tension force, and tension always acts away from the body. Okay, so that means the tension will be in this direction, and it will be capital T. Now over here you can see that as we are pulling this block of mass m3 in this direction with the force of capital F, this block will move in this direction, this block will move in this direction, and this block will move in this direction, right? So that means the block of mass m1 is actually moving in this direction with the force of capital A. So that means if I just write now, the net force along x-axis will be equal to your mass into acceleration along x-axis. Now over here, what is the net force along x-axis? See, on the x-axis only the tension T is acting, right? N1 and mg are acting in the y-axis. We'll not take that. We'll take the forces in the x-axis. So over here, so the net force along x-axis will be your capital T. Okay, so this will be equal to your, what is the mass of the body? M1. And what is the acceleration with which it is moving? F divided by your m1 plus m2 plus m3. So in this way you have easily found the tension in this string. Okay, we have easily found the tension in this string. Now suppose I want to find the tension in this string. Okay, so this string is actually connected with two blocks, m2 and m3. You can take any one of the block for analysis. I am taking this block of mass m3. Okay, so on this block of mass m3, downward will be our weight of the body, that is your m3g, right? Upward will be the normal that is coming from the ground. Suppose the normal is n2. Okay, now over here in this side you can see that we are pulling this body with a force of capital F, right? So that means over here in this side will be our force, capital F. And over here in this side you can see that there is this string. Now over here again, string will provide tension force, and tension always acts away from the body, right? So that means the tension will be away from the body in this direction. Okay, so that means over here again the body is accelerating in this direction with an acceleration a. So over here the acceleration will be in this direction and the value of the acceleration will be a. Okay, so over here I can write that the net force along x-axis will be equal to mass into acceleration along x-axis. So this will be valid. Okay, so now over here you can see that what is the net force along x-axis. See, so over here you can see that the block of mass m3 is actually pulled forward with a force of capital F. Okay, and the tension is trying to resist the motion. So the tension is acting backward and resisting the motion. So the net force along the x-axis will be F minus of T. Okay, total pulling force F खींच रहा है. ओके, टेंशन क्या कर रहा है? रिपोज कर रहा है. रिपोज मतलब पीछे खींच रहा है. सो दैट मीन्स द नेट फोर्स विल बी and which force will be greater, by the way? As the block is moving in this direction, obviously this force will be greater. So that means the net force along x-axis will be F minus of T. So over here this will be equal to your mass. What is the mass? M3. What is the acceleration? F divided by your m1 plus m2 plus m3. Okay, so over here if you can solve for tension T, and the tension T will come out to be, so over here if you solve for tension T, it will come out to be m1 plus m2 F divided by m1 plus m2 plus m3. Okay, so this is that simple. So we have found the tension in this string also, and we have found the tension in this string also. So with the help of this approach you can solve for acceleration and tension easily within a matter of seconds. So let's just proceed to the next example. Thank you. So proceeding on to the next question. So this is a very important question, so please see this mindfully. Okay, so over here there is the block of mass m1 which is placed in a horizontal ground which is connected to a block of mass m2. So over here we need to find the acceleration. So over here let us find the acceleration. So acceleration is nothing but your total pulling force minus the total resisting force divided by your total mass, capital M. So over here you can see that as this block of mass m2 is kept hanging vertically, it will move in this direction. So that means m2 will move in this direction, m1 will move in this direction. Okay, so over here we have discussed previously that the block which is kept in a horizontal plane, it will not give any pulling or any resisting force, right? So that means it will not give any pulling or any resisting force. But this m2g is acting vertically, right? It is hanging vertically. That means it will give a downward force of m2g. Okay, but over here in this case of block of mass m1, what was happening? Downward m1g force was coming, but it was balanced by the normal that is coming from the ground, right? So that means over here you can see that as m2 is actually moving away from the pulley, it will give us our pulling force. Why? Because all the blocks that move away from the pulley give us our pulling force. So over here you can see the so over here the pulling force will be provided by this block of mass m2, and it will be nothing but the weight of the block, that is your m2g. okay, and the net resisting force over here will be equal to your 0. Why? Because this block is giving us our pulling force and this block is neither giving any pulling or any resisting force, so that means the net resisting force will be 0. So from here the net acceleration will be equal to your m2g divided by your m1 plus m2. I hope I'm clear with this. So if you have any queries, just post it in the comment box. I'll be more than happy to answer you guys. So my homework for you guys is find the tension in this string. Okay, so find the tension in this string and put it in the comment section below, so I'll be more than happy to check the answers for you. So proceeding on to the next example. Over here in this example we have three blocks m1, m2 and your m3. So first of all, let us find the acceleration. Acceleration will be again total pulling force minus the total resisting force divided by the total mass, that is your capital M. So over here you can see that as m2 is your hanging vertically, it will move in this direction, right, and m1 will move in this direction and m3 will actually move in this direction, right. So that means over here you can see that as m2 is actually moving away from the pulley, right, m2 is moving away from the pulley se dur ja raha hai, right. So that means the net pulling force will be provided by this block of mass m2 and it will be weight of the block of mass m2, that is your m2g. Now over here you can see that we have discussed in the previous examples also that that neither m1 nor m3 will provide any pulling or any resisting force. They will never provide any pulling or any resisting force, right. So that means the net pulling force will be our m2g only, okay. And what will be the net resisting force? So over here you can see that the block of mass m2 is providing us with the pulling force. m1 is not giving any pulling or any resisting force. Similarly m3 is not giving any pulling or any resisting force, right. So that means the net resisting force will be 0. So from here the acceleration comes out to be your m2g divided by the total mass. Now what is the total mass? M2 plus m1 plus m3, that is your m1 plus m2 plus m3. Okay, so we have easily found the acceleration and the value of the acceleration is this. So I hope you guys have seen how to find the tension in the previous video. So my homework for you guys is find the tension in this string and find the tension in this string also. It's very easy. Just draw the free body diagram and write the equation of motion and it will easily get the tension. Okay, so let's just proceed on to the next example. So proceeding on to the last example, over here in this case we have three blocks m1, m2 and m3, and over here m2 is greater than your m3. So first of all we need to find the acceleration. So again acceleration will be equal to your total pulling force minus the total resisting force divided by this total mass, that is your capital M. So over here in the question they are stating that m2 is greater than m3. Okay, so that means over here what will happen? m2 will move in this direction because this side is heavier and this side is lighter, so that means this will move in this direction, right. So that means the block of mass m2, which is hanging vertically, by the way, it's moving away from the pulley, right, and this block of mass m3 is moving towards the pulley, right. So that means what will be the net pulling force? The net pulling force is provided by the blocks that are moving away from the pulley, right. m2 is moving actually away from the pulley, so that means the net pulling force will be provided by this block of mass m2. m1 will neither give any pulling or resisting force because it is sitting on the horizontal ground, right, and m3 is actually moving towards the pulley, so that means it will not give pulling force, it will give resisting force. So over here the net pulling force will be your m2g. Okay, the net resisting force over here will be all the blocks that will move towards the pulley. m3 is moving towards the pulley, right, so that means the resisting force will be given by this block of mass m3 and it will be m3g. Okay, now this block of mass m1 will not give any pulling or resisting force, and as m2 was giving the pulling force, you will not take that in the resisting force, so the net resisting force will be m3g, pulling force will be m2g. Okay, so that means the net acceleration is m2g minus of m1g divided by the total mass. Now what is the total mass? m2 plus m1 plus m3, right, so that means your m1 plus m2 plus m3. So in this manner we can easily find the acceleration of this kind of systems. Just the main concept remains is that all the blocks which are placed in the horizontal ground will not give any pulling or any resisting force. If you have cleared this concept, you can easily find the acceleration and tension of these these problems as well. Okay, so my homework for you guys is, again, first of all, solve for acceleration. Again, write it in your copy and then find these tensions T1 and T2. Okay, and in the comment section, do mention in this way that example 4 tension is this, example 5 tension is this. Okay, so thank you.